Okay, in this video, we're going to work through another example of finding and using a regression line. So this is based on the example from section 10.1 about the correlation between eggs and price. So in that last section, we found that the correlation coefficient for this set of data was negative 0.832601, and that there was enough evidence to conclude that there is a significant negative linear relationship between these two variables, the number of eggs produced and the price of a dozen eggs. So if there is a relationship, now we're going to go on and find an equation for that relationship, an equation for the regression line y prime equals a plus bx. If we're calculating it ourselves, we need to use these formulas for a and b along with the numbers for the sum of all the x's and then the sum of the y's and of the x times y and x squared and y squared values. So in the formula for A, what number goes here? It's the sum of the y's, which is 5.236. What number goes here? This is the sum of x squared, so that would be 7609557. In other words, 7,609,557. What number goes here? This part of the formula asks for the sum of the x's, and that's 5,709. And then here we need 4115.025, the sum of the x times y values. And on the bottom we have n, which is 6. There are 6 pairs of numbers here, times the sum of x squared, which is 7609557 again, minus the sum of x squared. So we're taking the number 5709 and squaring that. So when you put this into the calculator, you need parentheses around the numerator, divided by, parentheses around the denominator, and it should come out to be 1.251541. Then for b, we have n, which is 6, times the sum of xy, which is 4115.025, minus the sum of x, which is 5709, times the sum of y, which is 5.236, over the same denominator as when we calculated a. So 6 times 7609557 minus 5709 squared. And this comes out to be negative 0.000398. And so the equation is y prime equals 1.2515 plus negative, or just minus, 0.000398x. So that's how you would do it with the formulas. If you wanted to use Excel, the way I showed you in the last example, you would put in your data, your 6 pairs of x and y values. You would insert a scatter plot. So you'd ask Excel to make a scatter plot from that set of data. And then you'd go to add chart element, trend line, more trend line options, go down and click the box next to display equation on chart, and there it is. And remember, Excel puts the x term first. So instead of writing it as 1.2515 minus 0.000398x, it put the x term first and it rounded it to 0.0004. So negative 0.0004x plus 1.2515. When you do this, I would accept either way. You can put the x term first or second, but when I've been working the examples out, I've been putting the x term second just because that's the way our book does it. So that is the equation for the straight line that, out of all the straight lines that you could draw, this is the one that comes closest to fitting all 6 of these data points. So now, using that equation, let's find y prime when x is 1600, which would mean we're predicting the most likely price of a dozen eggs when the production level was at 1600 million eggs. So we take that equation, we plug in 1600 for x, and we do the calculations. 1.2515 minus 0.000398 times 1600 comes out to be 0.6147. So that's around 61 cents for a dozen eggs. Now, the last example we did in section 10.1 was looking at calories and cholesterol in a sample of fast food chicken sandwiches. We calculated the correlation coefficient, we tested its significance, and we decided that there was not enough evidence to show that there was a relationship between calories and cholesterol. So when that happens, when you do your significance testing and you conclude that there's not enough evidence to say that there's a relationship, then you have to stop right there. You shouldn't go on to find a regression equation or use it to make predictions. So that's it for section 10.2. The homework for 10.2 is on paper. It's the kind of thing that I've been doing in these examples here in these videos. I want you to do that. And when you do it, when you come up with the regression equations, you can do it however you want. You can use the formulas, you can use Excel, you can use a graphing calculator. If you have some other software or app that gives you regression equations, you can use that.